So now what we want to do is practice telling the difference between conduction, convection, and radiation. Make sure you pay close attention because I'm going to be telling you about some tricks that you can use to help you figure out which type of heat transfer they're talking about. You know now that in real life we always have conduction, convection, radiation. Heat is moving from object to object because the objects are touching. We've got heated air or liquid rising and falling, and any object that has heat in it, the heat radiates out in all directions. So what you'll have to do is try to figure out exactly what it is that they want you to notice in the picture. For example, let's look at this first picture. This is a space heater. We talked a little bit about them the other day. In a space heater, when we plug in the cord to the outlet, electricity flows through the cord, and then as the electricity flows through this teeny tiny coiled wire, the wire overheats, and eventually the heat spreads throughout the entire coiled wire. So this could be conduction because the heat's moving from particle to particle. But notice what they put in this picture. Arrows. Now, if the arrows were going up and the arrows were going down, I would think convection. But they're not. They're going out in all directions. So what do you think the answer is on this one? Yes, this one's radiation. The heat from this heater is radiating out in all directions through empty space. You would feel the heat coming off of it even before you got right next to it. Now, let's go to the next one. This is one of the pictures we used in class. There's lots of examples of conduction, convection, and radiation. But listen closely to my question. When these guys get up from their seats and someone else comes and sits in the spot they were sitting in, the stump they were sitting on will feel warm. Why? Is that conduction, convection, or radiation? If you put conduction, you're right. Their bodies are touching the stumps as they sit there, so the heat from their bodies flows into the stump. The particles in their bodies move fast and bump into the particles in the stump, and then the energy gets transferred. Oh, look at this one. We have arrows going up and arrows going down. Since they have arrows going up and down, they must be talking about rising and falling. Which one is this? Is this conduction, convection, or radiation? Yes, this is convection. When this radiator turns on, it's going to be the heat from it's going to touch the air particles around it. And the air around it is going to get heated up. It'll be less dense, so it'll rise to the top. And then the cooler air will sink to the bottom. And then it'll get heated up and just continue cycling. Look at this one. This man has a hot poker. He's got a poker stuck in the flames of the fire. What heats it up? Is it conduction, convection, or radiation? Yes, it's conduction. The poker was touching the flames of the fire. Remember, conduction is when heat transfers from particle to particle because objects are touching. It spreads eventually throughout the whole piece of matter. Notice his hands here. He won't be able to hold this much longer. What will he have to do? Yes, he'll either have to put it down or get some sort of insulated mitt to protect his hands. Oh, this picture looks familiar. There's liquid, and there's arrows going up and arrows going down. Is this conduction, convection, or radiation? Yes, you should have chosen convection. We can tell because the bottom part of the water is going to get hotter, so the particles will spread out. It'll be less dense. When something's less dense, it floats to the top. And then the denser material, the water that's away from the heat, is going to sink to the bottom. Oh, look at this. Someone's got this stick in the flame of a candle. Is this conduction, convection, or radiation? Yes, it's conduction, because this stick is touching the flames. Just one candle. Liquid in a tea kettle. Arrows going up and arrows going down. Which one is this one? Conduction, convection, or radiation? Yes, it's convection. This water's getting heated up It'll become less dense and rise to the top. The cooler water at the top will sink to the bottom. Then it's going to get heated up, and there's going to continue changing places. This is a great example. This is all three, but notice the arrows. There's arrows in the picture, but they're not going up and down, so it's not talking about rising and falling. Which one do you think this one is? Yes, this is radiation. The heat from the fire is coming off in all directions. Now, fireplaces, the chimneys, are actually a good example of how we use convection. Think about how chimneys are. There's a structure attached to the fireplace on the outside of the house, and chimneys always go up. Because those heated gases, the smoke from the fire, is less dense, it's going to rise to the top. And so, we don't have a chimney going straight out the side of the house, because the heated air has got, those heated gases are going to just get stuck up in the top of the fireplace, and a lot of it would come back into your house. What cooked this grilled cheese? Is it conduction, convection, or radiation? Yes, conduction. This skillet was touching the stove eye, so the stove eye particles bumped into the skillet, made them move faster, and then the skillet particles bumped into the bread and made those particles move faster until it cooked the bread. Conduction. Now, this is all three, but listen to my question. Notice on these ribs, there are the grill marks from the grill where it's been seared. What made those marks? Was it conduction, convection, or radiation? Yes, you should have chosen conduction. These marks were made where the ribs were touching the grill. Now, grills also use convection and radiation to help cook food. When you close the grill, you really cook the food fast because the heated gases that are rising from this from the grill get trapped inside when you close the lid of the grill, and your food cooks very quickly. There's arrows here, but they're not radiating out from something. I think the arrows here must represent wind. What causes wind? Is it conduction, convection, or radiation? Yes, convection. Remember, wind is caused when heated air rises in one place and then the cooler air sinks in the other location, and as they're switching places, that exchange of air is what wind is. Now, here's another question. Is this a land breeze or an ocean breeze? This is an ocean breeze. Remember, breezes are named after the direction they came from. This is coming from the ocean, so it's a sea breeze or ocean breeze. What about this one? What caused this ice to melt? Was it conduction, convection, or radiation? Yes, conduction. The ice was touching the person's hand. Remember, heat flows from warmer matter to cooler matter, so the heat from the person's hand flowed into the ice and melted it. Look at this cloud. Notice how it's going straight up. What caused this cloud to form? Was it conduction, convection, or radiation? Yes, this is one of those clouds that are nicknamed thunderheads. Notice how it's billowing straight up. Remember, we've got warm air in the area with water vapor in it. Yes, this is convection. This heated air here rises up to the top, and the water vapor that's in it starts to condense, turns back to liquid. Remember, cold air must be moving in the area, and that's what made the heated air rise. The cold air sank. Later on in the day, they probably have a storm of some sort. So what about this one? This picture should look familiar. Is this conduction, convection, or radiation? Yes, this is radiation. The heat from the sun travels through empty space until it reaches the Earth and all the other planets. And what about this one? Here's a picture of the sun again. Yes, this one's also radiation. Now in this one, we had some snow on a roof, and eventually the snow melted. Conduction, convection, and radiation, all three played a part in what caused the snow to melt. Look at the picture for a few minutes and see if you can figure out how conduction helped the snow to melt, how convection helped it, and also how radiation helped it. Now let's talk about each of these. One way that conduction helped the snow to melt was the snow was touching the roof. Since the people are heating their house, the roof becomes hot also, or it has heat in it because of the warm air in the home. And the warm roof was touching the snow, caused it to melt. But also convection helped it. Whenever they heat their home, the air in the home rises to the top because it's less dense, the heated air. And a lot of it collects in the attic. That's why the roof got hot to begin with. And then radiation. The sun's heat traveled the 93 million miles through space and also helps to melt the snow. Let's try another one. What about this? We have an arrow going up and an arrow going down. Which one? Yes, this is convection. Now, let's look at some of the definitions. This first one, this is where the heat transfer, where heated matter actually moves. The matter moves, not just the particles. It only occurs in liquids and gases. Yes, convection. Remember, solids can't convect. The matter needs to be able to flow and move around, rise and fall, and solids can't do that. Their particles are locked in place. What about this one? This is where heat transfers from particle to particle because they're touching, and solids are really good at this. Yes, conduction. Remember, the particles in a solid are already close together, so if you apply heat, they're going to bump into their neighbors. Which direction does heat travel? Is it from warmer to cooler, cooler to warmer, or warmer to hotter? Yes, A, warmer to cooler. Remember, our trick was it's trying to cool itself off. That's going to help you keep it straight. This one, heat traveling through empty space. No matter is necessary. Yes, C, radiation. Now, I want to show you a couple of the questions that you might see on TCAP about sea breezes. This is straight from the state's TCAP practice. And before we even look at the answer choices, I just want you to look at the picture. Notice we've got land and water. Also remember that they haven't told us whether it's day or night, but you should be able to figure that out because look, there's air rising over the land and sinking over the water. So what is this, the daytime picture or nighttime picture? Which one would be warmer? Which one would the land be warmer? Would it be during the day or the night? Yes, the day. The land heats up faster than the water, so during the day, the land is really hot. So you have warm air rising over the land, cool air sinking over the water. At night, it's the opposite. The land cools off very quickly, the water still holds its heat. So we have a breeze coming in from the ocean. So what kind of breeze would we call this? Yes, breezes are named after the direction they come from. This is an ocean breeze. Now, let's look at the question. It says, which statement best explains the movement of air shown by the arrows in the diagram? F. Cold air above the land rises. Wait a second. Cold air rises? Does cold air rise? No, let's get rid of that. Oh, cold air above the ocean rises. Cold air doesn't rise. So I'm going to get rid of F and G. Now I've got a much better chance of getting it right. H and J. Which of these explains what's going on in the picture? Warm air over the land rises and is replaced by cooler air from the ocean? Or warm air above the ocean rises and is replaced by cooler air from the land? Yes, this picture is H. Warm air over the land rises. Now, let's do one more. Notice that we've got 4 pictures here, and also notice there's no question. You need to pay close attention to the question I ask you. Also, I'm going to use this picture again on one of our quizzes, and it might not be the same question, so make sure you always pay attention to what the question says. Here's what I wanted to ask you. Which one of these pictures correctly shows a land breeze? Now, before we start trying to figure it out, we can get rid of any that are coming from the direction of the ocean. Remember, breezes are named after where they came from, So if we have a breeze that's coming from the ocean, right or wrong, we'll get rid of it, because the question is, which one shows a land breeze? So which ones can we get rid of? Yes, F and H. Look, F has a breeze coming from the ocean, so does H. So neither of these can be right on this question. So now we've got this one coming from the land and this one. So we need to look at the arrows now. This one's nighttime. We've got air rising over the ocean, sinking over the land. And this is daytime. Air rising over the ocean, sinking over the land. Which one of these is incorrect? One of these is wrong. Which one could not be the right one? Yes, J can't be right. This is a daytime picture. Would the water be warmer during the day than the land? No, the land heats up faster. The land is always going to be warmer. So the correct one on this one is G.